Hello students, this video is designed to help with the online learning week 2. We talked about polygons here and there were a lot of assignments on Khan Academy based on polygons. There was also a quiz. Before I get into answering the questions that you had, please make sure you send your questions to me especially before Friday. I was sitting around doing a lot of this on Monday, Tuesday, Wednesday, and Thursday. I know that people were trying to do their Khan Academy assignments, but please make sure that you're trying to do them over the course of the week, maybe about 4 or 5 assignments per day, so that if you have a question, you can ask me right away, so you don't have to wait for an answer, and I don't have to wait around for your questions. All right, let's take a look at one of the most popularly incorrectly answered questions. That was this question, the question with the big star in it. In this question, it asks the measure of angle x. Pause the video and see if you can do it now, and then come back to see if you get it right. All right, I recognize that this is a star, it's not a triangle, but you're supposed to make a triangle using the angles that you're given, trying to use as many angles as possible. So there's a lot of different triangles that I could draw, like I could draw this small triangle on top, but the triangle that I'm going to draw is a triangle with 47 and 31 already in it. And these two angles include this third angle here, so I draw the triangle that looks like this, and lo and behold, that angle that we're looking for is actually directly outside. It's an exterior angle of this triangle. So what we're supposed to do is first use the triangle sum theorem to try to figure out this missing angle. We did that here, and that angle is equal to 102. Then after that, we're supposed to recognize that 102 and x are supplementary angles. They form a straight line. So when I add 102 and x together, they should be equal to 180. Solving that, I get x is equal to 72, so 72 degrees. I should remember to put in the degrees here. All right, this was a fairly straightforward question. I know that it was a confusing shape, but all it was doing one triangle sum theorem and one supplementary angles. You could also have used the exterior angle theorem. Here's how that would have looked. All right, in this case, we use the exterior angle theorem. We knew that anterior angle plus interior angle is equal to that exterior angle over here. So we add these two angles together and we get 78. That's an alternate way of doing this problem. Moving on to the next problem that a lot of students got wrong. This was a problem using parallel and perpendicular lines. Pause the video, try this out, and see if you can get it right. All right, let's see if you can follow the steps here. That first step we're going to take is vertical angles. We know that if this angle is 70 degrees, then this angle must be 70 degrees. These two angles are vertical. In other words, they share the same vertex, and they are on opposite sides of that intersection. Second thing we can do is say that perpendicular lines form right angles. Since KL and FG are perpendicular, that's these two lines, that means that this angle here is 90 degrees. That means it is a right angle. The third thing that we said is the triangle sum theorem. We know that these three angles add up to 180, so I was able to do 90 and 70 together, that's 160, and that means that CAB is equal to 20 degrees. Last but not least, I'm going to use that vertical angles again. I know that this angle and this angle are vertical angles. They share the same vertex, and they're on opposite sides of the intersection, so 20 degrees goes up here as well, so 20 degrees is equal to x. That was a 4-step process, but all these steps are very easy. This one means that two angles are equal to each other. This one means that one angle is 90 degrees. This angle is adding 3 numbers equal to 180 degrees. And again, this is vertical angles, which is two angles are the same as each other. So not too bad. Moving on to the next problem that was on Khan Academy. This was a question that was very similar to the other question, but it asked for a slightly different thing. Pause the video, try this out, and then come back to see if you got it right. All right, here was another example in which you had to just find a triangle and try to make it work. You can see that there's an angle here, an angle here, and an angle here. There's no way to combine 2 of these 3 angles to make a triangle, unfortunately. But there's another way to do this. I drew this triangle here because I knew that I knew this angle, and I knew something related to this angle, which is 107, and I knew something related to this angle, which is x. So what I was able to do is start from one piece of information, this 107, and use the supplementary angles theorem, which means that 107 plus something is equal to 180. That's 73. Then I use the triangle sum theorem to say that, well, these 3 angles, I know the 73 and I know the 31. I know that they add together to give me 180 if I add this third angle in there. And that third angle turns out to be 76. Last but not least, I use vertical angles to determine that if this is 76 degrees, this must also be 76 degrees. They're very similar to the previous example in which we had to use several different theorems. All we had to do is figure out which one to apply where. And in order to figure out which one to apply where, we look at the diagram. This is a situation in which we use vertical angles because they're sharing the same vertex and they're across from each other. Same thing here. These are vertical angles because they share the same vertex and they're across from each other. Identifying the relationships between the angles is the important part of this. The rest of it is just very simple add, subtract, multiply, divide algebra. Moving on to the next question that students got wrong. In this case, we know that these two lines are parallel, and it asks what's the measure of angle x. There's a relationship here. Let's try to figure it out. Pause the video, try these out, and then see if you got it right. All right, in this case, I didn't know anything about angle x specifically, but I did know these two angles are two angles of a triangle. So I used the triangle sum theorem first to find that BCA is equal to 33 degrees. The next thing I used was the alternate interior angle theorem. We remember that alternate interior angles are formed by two parallel lines. We know that BC is parallel to DE. And we also know that if we draw this Z shape, then this angle here on the inside of one crook of the Z is equal to this angle, which is on the other side, the other inside of the other crook of the Z. So 33 degrees up here, 33 degrees down here. Another example of alternate interior angles, which is a theorem that you know from the Khan Academy videos, and you also know from previous units in geometry. Moving on to the final question, the penultimate question that we're going to look at from Khan Academy. Pause the video, try this one out, and see if you can get it right. This one could have been approached with two different methods. You could have used supplementary angles to find this angle and then use the triangle sum theorem. But I think in this case, the exterior angle theorem was a lot more tidy. For one, you only needed one step. And for the other, you only needed to identify two angles, two interior angles, and one exterior angle. And remember that these two interior angles must be remote interior angles. In other words, they can't be the one that's right next to the exterior angle. Anyway, the exterior angle is equal to the two interior angles together. So these two interior angles added together here, exterior angle here, solve it up, x is equal to 56. This was a very straightforward question if you knew the exterior angle theorem, which you should. Last question this time. This is the last question from the Khan Academy assignment. Please pause the video, try this one out, and see if you can get it right. Here again, we have a situation where we have a couple of different theorems that we could use. One thing that you could have done was identify that this was 42 degrees and then therefore this was 42 degrees using alternate interior angles. And then you could have used the supplementary angles theorem to say that this angle plus this angle plus this angle is equal to 180. That's an interesting way to do it. Another way to do it is simply by using the triangle sum theorem here and then using alternate interior angles here. As you see more and more of these problems, I talked about this when we did this unit in class. As you see more and more of these problems, you'll be able to see that there are multiple different ways of getting around these problems using the different theorems that we have used in class. All right, I want to move on to the quiz, the week 2 quiz. There were a couple of questions from students on this, and remember, as I said at the beginning of the video, please make sure that you're asking me questions earlier in the week because at the end of the week on Friday, the quiz is due, so you won't be able to ask so many questions. Anyway, pause the video, try this one out, and then I will show you the correct answer. All right, the first step in answering this question correctly is to label the diagram completely. ABF is 134, that's angle ABF. GFB is 96, here's GFB from G all the way to F to B. And we are also looking for the measure of angle ACG, which is here. Now that it's labeled, you're able to use the same procedures that we used on the Khan Academy videos to try to figure this out. Again, we're trying to use whatever theorems we have. All right, you can see that we followed a very similar procedure to the other questions. We looked for the relationships, and one at a time we put the pieces together until we got the missing piece of the puzzle. Supplementary angles for the first one, that's in blue. Triangle sum theorem, that's in red. And then supplementary angles again, that's in green, finding this angle. You could have used exterior angle theorem here. You could have gotten this 38 degrees one step earlier, so you would have only needed 2 steps, but I like to do it this way because it shows all of my thinking. If you used exterior angle theorem, that's totally fine. Moving on to the next question here, this was a question that required you to watch the video about the different types of quadrilaterals. If you had done so, you would have known all of these vocabulary words, including rhombus. If you had not, then you wouldn't have known how to do this question. Pause the video, try this out, and then see if you got it right. All right, Jafet was incorrect. He drew a parallelogram because 2 pairs of opposite sides are parallel. These marks do mean parallel, right? This arrow and this arrow means they're parallel to each other, and these 2 arrows mean they are parallel to each other, but not parallel to the previous ones, which is obvious because this line and this line intersect each other. However, we don't know if the sides are congruent. Nothing here says congruent. Remember, these arrows don't mean they're the same length. These arrows just mean they're parallel to each other. So you did not give enough information of drawn a rhombus. Sorry, bud. For this next one, Stephanie drew a square. And if you had said she drew a square and she is wrong, oof. Remember that a square has 4 congruent sides and 4 congruent angles. Since it's got the 4 congruent sides, and since it is a type of parallelogram, it does still have the properties of a rhombus. A square is a type of rhombus. It's also a type of rectangle. A rectangle is a type of shape with 4 right angles. A square is a special kind of rectangle. It's also a special kind of rhombus. So anyway, we know that she did draw a rhombus. So she rocks. All right, moving on to the next page here. Question number 3 was a word problem which required you to draw a diagram. Pause this video, draw this diagram, and then see if you got it right. All right, you can see the first thing I did was annotate the problem. I found out that it was a 5-sided polygon, this pentagon, and I drew it. It doesn't have to be to scale or anything like that. As a matter of fact, you just draw any old pentagon and it should be fine. It gives us these 4 angles, so I plugged in those angles there. And this 5th angle, which is x degrees, I don't know it. That's the thing that it's asking us to find. So what I did was I used a formula that I know already. The formula is the sum of the interior angles of any polygon with n sides. Any polygon at all, whether it's a triangle or a quadrilateral or a pentagon or a heptagon, whatever the case may be. 180 times n minus 2 is the sum of the interior angles of any polygon. Well, for a pentagon, that n turns into a 5 because there's 5 sides and 5 angles. 180 times 5 minus 2, which is the same as 180 times 3, that's 540 degrees. So now what I need to do is use an equation to figure this one out. Here's the equation in question. We're calling it the pentagon sum theorem, but it doesn't have to have any special name. It's just that all the angles in a pentagon equal to 540. So we add all the angles together, that equals to 540, and then we do a little algebra. X is equal to 40, but of course it should be 40 degrees. Using the correct units is important. Moving on to question number 4, this was a situation in which you were also not given diagrams, but you had to draw them out, and you also had to explain why a side was either possible or impossible. All right, pause the video, try these one out, and then see if you get them right. The basis of this entire question is the triangle inequality theorem, which says that the small plus the medium side of any triangle has to be greater than the large side. If they're not greater than the large side, that means that the 2 sides, the small and the medium, won't be able to connect based on that large side. So what we're going to do is we're going to figure out 2 different scenarios. The scenario in which we don't know the smallest side and the scenario in which we don't know the largest side. Pause the video, try that out, and then see if you got that right. All right, we can tell that the smallest side is going to have to be greater than 6.3 centimeters, and the largest side has to be smaller than 10.5 centimeters. So that side, from smallest to largest, it has to be between 6.3 centimeters and 10.5 centimeters. A quicker way to do this is to take these 2 numbers and subtract them and add them together. If you add them together, you get 10.5. If you subtract them, you get 6.3. Now we can figure out which is a possible third side and which is an impossible third side. All right, all I had to do was pick a number between 6.3 and 10.5, so I decided to pick 9. 9 is a possible third side because it is between these 2 numbers, or in other words, it fits the triangle inequality. All right, so similarly here, I had to pick a number that did not fit the triangle inequality. 3 is the number that I picked because it doesn't fit in between 6.3 and 10.5. It's smaller than 6.3. Moving on to the last question here, this is a question about parallelograms. You knew about parallelograms because of one of those videos. Pause this video. Speaking of videos, try this one out and then see if you got it right. All right, the first thing I did here was annotate, and I wrote down the different angle measures that I knew. Now what I have to do is think about the properties of parallelograms to figure out what else I can label in this diagram. Try to figure out what else you can label in the diagram and then see if you got it right. All right, one lovely thing that I know about parallelograms is that their opposite angles are congruent. So in other words, this angle and this angle are congruent, this angle and this angle are congruent. Now there's one more property that you need to remember. Pause the video and try to remember that one. One very worthwhile thing to know is that in a parallelogram, actually in any quadrilateral, any 4-sided shape, the interior angle sum is 360 degrees. So I was able to add all these up to equal 360. Solving the equation gives me x equals 16, and many students stopped there, but it did ask me to find angle r. So the last thing I'm going to do is find angle r. Pause the video and try that one out. All right, luckily for us, it was just a simple substitution. 3x plus 12 is the measure of angle r as stated previously, and I know that I can substitute in 16 for that x to get that answer. All right, this was the video about Online Learning Week 2, the Polygons unit. Hopefully you watched all those videos and tried these quiz questions. Again, if you ever have any questions during the week, please make sure you send your questions to me, preferably before Friday. I'm just sitting here twiddling my thumbs, waiting to make videos for you. All right, good luck studying.